So all of you observe in this gravitation chapter, first we studied what is Kepler's laws. So the three Kepler's laws we have discussed. The three Kepler's laws is most important. So once again, you are going to study in the 11th class. So Kepler's laws of planetary motion. So if you have taken here Kepler's laws of planetary motion, so we have learned totally about the three laws. So the first law will says that first law also we can call it as what? Everybody who is to call it as law of, yes please, law of orbits. Am I right, all of you? So what first law will says that, so if you have taken the planets are revolving around the sun in a elliptical shape, and it will be having a two axis. One is minor axis, another one is what axis, everyone? One is minor axis, another one is what?
Major
Major.
axis.
Now, this major axis is having two focus. That is what is the plural form of two focus, everybody? You all should involve foci. So it will be having a two focus, that is what? F1 and as well as F2. Now sun is present at any one of the foci, either here or here. The sun is located at any one of the foci, and the planets are revolving in a particular orbit. That is what we used to call as law of orbits. Understand, everyone? So second one, law of areas. When the planets are revolving around the sun, so in a particular orbit, so always in a given period of time, of course we know when the planets are moving closer to the sun, they'll move faster or slower, everybody? They will move faster or slower, everyone? Faster, because of more gravitational pull. And when they are moving far each other, the speed of the planet will decrease. So whatever it is, in a equal interval of time, the planet will cover the equal area. It will sweeps the equal area. That is only we used to called as second law of planetary motion, which we used to called as Kepler's second law. What we used to call, everybody? Law of
Area.
law of areas. That is what we have discussed it. Then third one. So if I have taken around the sun, there is a many planets revolving around the sun. So every planet is having a different time period and different average radius from the sun. Planet number 1, planet number 2, planet number 3. So they all are at different distance from the sun. Let me take the average radius is R3, R2, and R1. And the time period is T1, T3, T2, and T1. So different planets is having different time period to revolve around the sun, and they are having different average radius from the sun. So what is that, everyone? What is Kepler's third law? Kepler's third law also we can call it as what? All of you. Law of
Periods.
law of periods, it will says, Ma, don't be sit silently. You all should involve and you have to speak. This is your class, it's not my class. So law of periods. Law of periods will says that if you do the time period, the square of time period of any planet is directly proportional to cube root of average radius. Any planet if have been done. So if I've taken planet number 1, so time period, square of time period of planet number 1 divided by cube root of planet number 1, which is equals to time period, square of time period of planet 2 divided by cube root of average radius of the planet number 2, which is equals to so on, remains what, everybody? Remains it is constant. You will get the same number. If you do the square of time period of any planet divided by cube root of average radius of the planet, we always will get the same number. That is what we used to call it as law of periods. Or you want, you can do the reverse also. Cube root of average radius divided by time period square of cube root of average radius divided by time period of second planet, which is always remains what? All of you please respond. Remains constant. Anything you can do it. That is only called as, what is to say, law of periods. This is what we discussed first in this chapter. So three laws are very, very important. So there is a connectivity between Kepler's laws and in Newton's universal law of gravitation. What is another name of universal law of gravitation? Everybody?
Newton law of gravitation.
Yeah, Newton's law of gravitation. That is only we studied that. So Newton's law of gravitation also we can call it as Newton's law of gravitation. Also we can call it as universal law of gravitation. So this is universally accepted law. According to that, what it will say is, you take any two bodies in the universe, the force exerted, the force of attraction between them is directly proportional to what, guys? The force of attraction between them is directly proportional to, please respond, everybody.
Product of the
Product
masses.
of their
Product of their
masses
masses.
and inversely proportional to square of distance between the two bodies from their centers. That is only, this is only we used to call something. What is that called, guys? Everybody.
Inverse
Inverse square law. We used to call it as inverse square law. So this with the help of this only Mr. Newton, with the help of Kepler's laws, he derived the inverse square law. That is also I have taught you. So F is equals to, all of you remember, sorry, F is directly proportional, inversely proportional to square of distance between the two bodies. Square of distance between the two bodies from their what? From their, everybody,
Center.
from their centers is only called as inverse square law. So now if I combine these two, I'll get the formula F is directly proportional to product of their masses and inversely proportional to square of distance between the two bodies from their centers. If I remove the proportionality constant, I need to take the equals to sign and I have to multiply with the constant into capital M into small m divided by d square, which is equals to F. This constant only we used to call something. Everybody, what we used to call?
capital G.
Capital G, universal gravitational constant. Universal gravitational constant. Even I have given much practice, exam, nothing has been done by few fellows. Universal gravitational constant. So that is what I have taught you. So what is that, everybody? So every planet is revolving around the sun in a solar system. That force only we used to call it as centripetal force, or we can say center seeking force. The center seeking force only we used to call it as what force, guys? This is only the last question.
Gravitational force.
That force only called as gravitational force. This is also don't know, Mr. Mukesh, for you. You have not written this. That's why I'm very angry on you. Okay. So the centripetal force only we used to call it as gravitational force. And this gravitational force or centripetal force is depends on two factors. What is the factors which will affecting? One is mass of the objects, and second one is what, Amma? Distance between them. That's all it is. Do you understand? The
Sir, I wrote force due to gravity,
Yes,
sir. Is
ma'am.
it correct?
The centripetal force is only we used to call as gravitational force. This gravitational force is depends on what? It is depends on masses. Do you understand, Mari? It is not due to acceleration due to gravity. Okay, ma?
Sir, force due to gravity.
Yeah, force due to gravity. Force due to gravity is depends on mass. Do you understand it? It depends
Yes,
on the
sir.
mass. You can say that, nothing wrong. And as well as distance between them. The force due to gravity means mass and distance only. Are you clear?
Yes, sir.
That is what. So it's right only. It's nothing wrong. Okay. So that is what you have to remember. So the gravitational force is depends on distance between the two bodies and mass of the two bodies. So with the help of this, we have been found the formula. So what is the formula? Universal law of gravitation. F is equals to, all of you, capital G into capital M into small m divided by d square. This is the formula to calculate the force of attraction between any two bodies in the universe. Not only particular celestial objects or terrestrial objects. Again, I'm saying terrestrial objects means objects which are present inside the atmosphere. You, me, your house, in my house, these all are called as terrestrial objects, which are present inside the atmosphere. Outside the atmosphere, for example, Mars and Earth, Mars and Moon, Mars and Sun, these are called as celestial objects, which are present outside the atmosphere. You take any two objects, celestial or terrestrial, doesn't matter. Always the force of attraction between any two objects we can calculate with the help of this formula. That is why it is called as universal law of gravitation. Are you clear, everybody? So this is what we studied that. So from that we calculated even the G value. Mr. Who has been Henry Cavendish is given the G value. He has been derived. What is that value, everybody? 6.67 into 10 power 10 to the power of minus 1. And what is the unit of capital G, everybody?
Newton
Meter square per kilogram square. That Hasini also, still you are cheating, Hasini, you are not 100%. Compared to you, Prince has been done well, really I am saying. You remember. Because there is no, if like what, desire to study. You are not interested to study. That is what I am saying it. Okay, everybody. So this is what it is. 6.67 into 10 to the power of minus 11 Newton square meter per kilogram square. That is what capital G value we have been found it. Then what we have studied, everybody, how it will be affected, the factors. Every factor I have taught you, distance become double. This question, most of them they have done well, except one or two, all of you. And then what we have discussed after that, we have studied that how that Newton's second law will be like affected, that small g, that's what, force of gravitation, acceleration due to gravity. So acceleration due to gravity, according to Newton's second law, F is equals to ma, and we all knows that. Or if it is a free fall, it will become what? mg. So, and this one, F is equals to capital G into capital M into small m divided by d square. If I equate this both, I'll get it. mg is equals to capital G into capital M into small m divided by d square. Small m will get cancelled. So I'll get the G formula, small g formula. What is the relation between small g and capital G, everybody? Relation between small g and capital G. Small g is equals to capital G into capital M divided by what, everybody? D square. Understanding, all of you? Please respond. So that is what it is. And what is the G means what, everyone? What do you mean by G? Acceleration due to, please respond. Acceleration due to gravity, which we used to call as small g. So what is the unit of small g, everyone? Small g is equals to acceleration.
Meter per second.
Yes, please. Meter per second square. Yeah. Meter per second square. Now, relationship between capital G and small g, we have been calculated. If I take any planet, if I take Earth, if I take Moon, if I take Sun, if I take Jupiter, I have taught you all this case. Even I have given you the tabular column also. Am I given or not, everybody? Tabular column, all the planets, their radiuses and everything. So if you have noticed it, if I keep 1 kg object on its surface everywhere, what is the gravitational force? That is what acceleration due to gravity of every planet. So we have been, the distance between the two objects from their centers, we have been considered as equals to the radius of the planets. So we have been replaced that. For example, gravity of Earth, if I have taken, what is the formula, everybody? Capital G into mass of Earth divided by, instead of D, D means what? Radius of the Earth. So radius of the Earth square. That is what is the formula to calculate the gravitational force, acceleration due to gravity of Earth. That is what we have done. So if you have taken a moon, what will happen? Gravity, acceleration due to gravity of moon, which is equals to, remember, for Earth alone, I can call it as a gravitational force, or I can say gravity. But other planets only I should call it as what, everybody? Acceleration due to gravity. Remember, it is a gravitational force. Only Earth alone I can call it as a what? Either gravitational force, or I can call gravity. Okay, because we are living on the Earth, so that is why Earth we can call it as a, we can call it is a, we can say it is a gravity. Okay, but if you notice it, all of you, for moon, if you have taken, we should not call it as a gravity of moon. You should call gravitational force of moon. So gravitational force of moon, what is the formula? Capital G into mass of a moon divided by, you say, what will happen? Square of radius of moon. If I had taken a Jupiter, exam, I think you got the Jupiter. Am I right, everybody? So Jupiter G is equals to, what will happen? Capital G into mass of Jupiter divided by radius of Jupiter square. That's all it is. So like that, any planet you can use. And I have given you a tabular column also to calculate. That is also not done by many people. I don't know why it is. Even simply, and I told you before itself, learn the radius of the earth and mass of the earth. What is the mass of the earth, everybody? 6 into 10 to the power of, how much, Ra? 6 into 10 to the power of 24 kg.
24.
And the radius of the earth is how much, Amma? Radius of the earth is 6.4 into 10 to the power of. Yes, please. Radius of the earth, Ra?
6.
Yes.
6, sir.
6 or 6.4? Radius of the earth.
6, sir.
6.
6.4.
That is what? 6.4 into 10 to the power of 6 meters. Mr. Darshan, you have not done this because you not learned the radius of the earth and mass of the earth. You have simply written the statement. Acceleration of the earth is 9.8. How you are going to get mark? I ask you to calculate the G value of the earth. You should write it. You have to write the mass of the earth. You have to write the radius of the earth. And you have to substitute in the formula. And you have to calculate it. That is the 2-mark question. Purima, simply you are not going to get anything. That's what I am saying. I already told you even exam before. You should learn the mass of the earth and radius of the earth. Because it is a very familiar thing. It is not going to be asked. Any other planet means you will be getting. And mass of the Jupiter. What is the answer? You got it, everyone? Already we have solved it also during the practice time also. What is the mass of the Jupiter? Gravity of Jupiter, will get it. 27.22 meter per second square. Calculations, very few only they have done well. I think Danishka has been done very well. His calculations and all. Mr. Lingesh and all okay. But remaining, I don't know. Many people, they have been made mistakes. So that remaining sections, you have to verify yours. How much you have been done. That's what it is. Okay. Hasini, you will receive, Hasini Sudhakar, you will receive the question paper. I think today I will send the photocopies. Okay. You have to solve it and you have to send me all the questions of physics at least. Okay, wa?
Okay, sir.
Yeah. So that is what is the formula. So now, this is what is the relationship between small g and capital G, which we already studied. Now, you remember G value is maximum. G value is maximum for any planet only on its surface. Please note it. Only on its surface, it is having G value is maximum. If I go above from the surface, upper, G value keep on decreases. If I go deeper into the towards to the center of the planet, then also G value decreases. If I go downwards or upwards, G value decreases. Now, we are going to study in our today's class, what is the parameters, like we can say, how much, who will be affecting, what is the parameters affecting this G value. That is what we are going to see. One is altitude, second one is depth. These are the two things I'm going to teach you now. So let us discuss now the first one, all of you keep. So anybody having any doubt? I think free fall, you all very familiar. So what is the free fall equations, everybody? V is equals to U plus GT. Second equation, H is equals to UT plus half GT square. And third equation, V square is equals to U square plus 2GH. I think free fall, you are all very familiar. Many of you have done correctly only. So I don't think so you are having any difficulty. If you have any difficulty, once again, we'll solve that also. Are you clear, everyone? Please respond, guys. All of you?
Sir.
Yes. So today's class, we are going to discuss the most important thing. Mr. Lingesh, give proper name. Is it the number way I have given you? Just verify it. So that is what you will all will experience it also. Just remember new thing. So acceleration due to gravity. Factors affecting it. Keep heading all of you. Acceleration due to gravity. Factors affecting it. Factors affecting it. For example, as I said, where you will experience the maximum gravity, everybody? Where you will experience the maximum gravity? All of you, please respond. It is
Yes, sir.
surface. So every planet, if you take moon or sun or earth, only at the surface, it is having the maximum gravity. Are you clear? Now, if you have taken G value, capital G value, universal gravitational constant, it is throughout the universe, it is remains constant. But small g is not constant. Small g is not constant. It is throughout the universe. So if you have taken, even on the surface of the earth, if you have taken, it will be varies from place to place. That is already we studied it. Of course, once again we'll study. Now, for example, if I taken the first factor, factors affecting it, that is only major importance of our today's class. That is what? Altitude. Okay. Now remember, I am on surface of the earth. This is what is my earth. Now I am on the surface of the earth. So what is the G value? Can you tell me? At this G value of the earth, everybody respond, guys. 9.8 meter per
9.8.
second square. Are you clear? Agalya? Now, we all know G value formula. Can you tell me G value formula, everybody? Capital G into capital M divided by radius of the earth whole square. Clear, everyone? Now, if I am going, suppose I am standing on the earth, so that my acceleration due to gravity is 9.8 meter per second square. If I climb to some height, h1 height, if I climb to h2 height, if I climb to h3 height, I am keep on going above. I want to find what is my G value about this height. What is my G value about this height? What is my G value about this height? As I said, if you are keep on going up, G value decreases or increases? Everybody. Yes, please. G value decreases or increases? Not only for Earth, any planet, it will be keep on. Please respond, guys. Decreases. Understand? For example, if I am at 0 kilometers height, means on the surface, what is the G value, guys? Please respond. Altitude. Altitude, yes, please respond. Altitude in kilometer. I mean 0 kilometer. What is the G value, guys? Everybody. 9.8 meter per second square. If I move 500 kilometers above 500 kilometers above from the earth, remember, my G value of the earth is 8.28. Do you understand, Mari, what I am saying? Mr. Lingesh, Kishore?
Yes, sir.
That is.
Decreases.
Yeah, decreases. If I go to 1000 kilometers, the G value falls into 7.34. Same Earth. Earth alone I am talking. It's not about some other planet. Do you understand, girls? Everybody? Abhirami, Niroshi, Alfin. Now, for example, I traveled 6,371 kilometers. Then, you remember, just drastic change. G value comes to 2.46. If I travel 10,000 kilometers, G value comes to 1.49. If I travel 30,000 kilometers, G value is approximately 3.1, 0.301. If I goes more than 45 kilometers, 45,000 kilometers, remember 45 greater than 45K, then remember G value is approximately 0. Means you are in a, where? You are in like flying, zero gravity area. Understanding, everybody? Zero gravity zone. Means you are in a space. Do you understand, all of you? Yes, please. Please respond, guys. So by the time you will be started flying, you cannot be moved forward, upward and down. That is what. So altitude is keep on increasing. G value is keep on, what will happen? G value will be keep on. Yes, please, guys. G value is keep on decreases. Understanding, Nivedan? So how to find it? Sir, what is the way to calculate?
Near to 40.
Yes. So if the G value is keep on increasing, that's what the altitude is keep on increasing. If you are going above from the surface of the earth, then the G value keep on decreases. Now, for example, I'm standing here. I travel to some x distance above from the ground. Now what is my g value at this height? I want to calculate it. So where it is showing the maximum, everybody? Where it is showing the maximum? Please respond. Where it is showing the
Surface.
maximum? At the surface.
Surface.
Surface it is maximum. Now I want to calculate the g value here. So what is the formula? Any planet, not only for Earth, you can take any planet. So g value at this height is equals to, now Earth alone we are studying, which is equals to formula g value of Earth at the surface, g value of Earth at the surface divided by 1 plus h by r whole square. That is the formula.
So this is to find the altitude also.
Yes. No, this is to find the g at a given altitude. Are you clear, Mari?
Yes, sir.
Find the g value at a given altitude. This is the formula we'll use it. Clear, everyone? All of you? Please respond. Any doubt, anybody can ask.
Yes, sir.
The G in the sense the surface. Gravity.
Yes. G means the gravitational force at the surface. Okay, wa?
At the surface.
Yeah. Girls understand, ma? Hasini, Agalya, Sangamitrai. Sangamitrai have done very well. Really, I'm happy. There is a really drastic change. She has been done extremely well. Particularly science, chemistry, biology also she's done very well. I'm really happy. You have to work, Sangamitrai. Like this, you work means definitely you can make 470, 480 in 10th class. Okay? Every subject you have to work like that.
Yes, sir.
Yeah. Next. Now see, if this h values keep on increases more and more than like r. R means what actually? Radius of the Earth. What is r, everyone? What is that, everybody? Radius of the Earth. Understand it? Radius of the Earth. It is keep on increases more and more and more. When h is less than r. Understanding? Means h value is very small, smaller than the r. Then the relation is approximately, you can modify it. Then small g is equals to, means at a given height, which is equals to g at surface into 1 minus 2h by r. This derivations I will teach you coming classes, how it will be coming. So this is the formula when h value is very smaller, like you want to find it 1 kilometer above, 5 kilometers above, 20 kilometers above, 30 kilometers above. Do you understand, Amari? Lingesh, what I'm saying? If it is h is a greater height, like 20,000 kilometers, 30,000 kilometers, you can use this formula. If it is approximately very lesser than the radius of the Earth, then you can go with this formula to calculate the g value. Are you clear, everybody? Please respond, guys. Yes?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So this is what is about, like for example, you can calculate 5 kilometers above. I went 5 kilometers above from the ground, calculate the g value. Then which formula will use? It is very less than compared to the radius of the Earth. So what will happen? We have to use which formula? This is the formula. Clear, everybody? If I travel, for example, 5,000 kilometers, then it is almost equals to radius of the Earth. Then we can go, it is like a bigger value, it's not a smaller value. Then we can use this formula. Do you understand, Rakishore? Lingesh, everybody? Yes? All of you? Please
Yes.
respond. That is
Yes,
what.
sir.
Girls, anybody having doubt, you can ask me. So of course, we'll solve the numericals also so that you all understand it. So the next parameter, second, depth. Second parameter is what, everybody? Depth. Now, again, same thing. So what will happen, everyone? You can notice it. If I am on the surface of the Earth, my g value is maximum or minimum? If I am surface on the Earth, my g value is maximum or minimum? Everyone? Yes, please respond.
Maximum.
Maximum. Now, I started moving towards to the center of the Earth. I started moving towards to the center of the Earth. So this is the center of the Earth. I started moving. Now see, actually from the surface, that is called as what? Actually, we used to call to the center of the Earth, we used to call something. Anybody can tell? What is that called as? From the
Center.
surface, guys. Hello. From the surface, we used to call towards to the center. We used to call the distance between them. We used to call something.
Radius.
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 What is that? Radius. Do you understand, all of you?
Radius.
So if it is at the surface, we can say G value is equals to capital G into capital M divided by radius square. So that we are getting the maximum 9.8 meter per second square. Now, let us start digging, and I went to this depth. So let me take this is D1, and I went to D2 depth, and I went to D3 depth. Finally, I reaches to the center exactly. So if I reaches to the center exactly, then R become what, guys? R become what? Everyone? 0. Am I right or wrong? 0. So that G value also become what? Yes, please. 0. So whenever R becomes 0, the entire G value also becomes 0. So if I reaches to the center of the earth, what is my acceleration due to gravity? Everyone, what is my acceleration due to gravity? 0. Do you understand it? Because their radius is 0. So the 0 is like G value is also 0, where the center of the earth. Any planet, if you reaches to the center of the planet where R equals to 0, then G value also becomes 0. At the center, or we can say center of mass, COM. At the center of mass, the net force of attraction acting on the body is 0. So that acceleration, that is what? Because R becomes 0, G value also becomes 0. That is what you have to remember. Now, I want to calculate at this depth. So I started digging and I came to this much. This is what is the D depth I went. Now, I want to see that this total is R and I traveled already D depth. Now I want to find remaining distance. How to find it, guys? Mathematics, can you tell me, anybody? What is this remaining one? R minus D. Will you all agree with me? Mr. Nivedan, Lingesh, Agalya? Yes or
Yes,
no?
sir.
This total is R.
sir.
And I went inside the earth D distance. So that remaining distance is how much? How much distance away from the center? R minus D. So if I want to find at this depth, I want to find the gravitation force. Then GD is equals to, please keep it in mind, gravitational force of earth on the surface, G, into 1 minus D by R. 1 minus, yes please, 1 minus D by R. This is the formula. You can calculate the depth at any G value at any depth from the surface of the planet. So this is the formula. Derivations, we'll study that. Anybody having doubt, you can ask me. Are you clear, everybody? Yes, please respond, guys. All of you. So what is the formula?
Sir, we need to write 2D, sir. 1 minus 2D.
1 minus D, Mari, not 2D. That is different formula, Mari. Before you studied for altitude, height.
Yes, sir. This is for?
This is for depth, second parameter, second affecting parameter, depth it is. You are going
Yes.
inside the earth. Understanding?
Yes, sir.
Yeah. We go deep into the earth below its surface. Then this is the formula for calculating G value at any depth. Understanding?
Yes, sir.
Clear? Anybody having any doubt? Please let me know. Are you clear, guys? Boys, girls, everybody?
Yes, sir.
Yeah.
Sir, can I please show the screen again?
Yeah, you can take it. There is a third parameter which we already studied. That is what? Latitude. So we all knows that Earth is not a complete sphere. It is having a flat surface at where? Everyone? It is having a flat surface at the poles. Of course, we'll study that. You can finish this work. Okay, I'll send the second meeting. You join back and we'll finish that and then we'll end up. Make it fast, everyone. So do you understand how to calculate at any depth? You can use this formula to calculate the G value. Are you clear, Niroshi? Alfin,
Sir?
I'm calling you. Yes, tell me.
Sir, it's okay, sir.
What? Are you clear?
Yes, sir, I'm clear. It's okay.
Well, I'll teach you the derivations also. No issues. Now you can see meeting is going to end. Join back. So now the third parameter is, we all people knows, altitude. So yeah, altitude is over and depth is over. The next one is latitude. So latitude means social you people study what is latitude and longitudes. Okay. So now you can see already we have seen an Echand book also it is there. So Earth is not a completely sphere. It is having a flat surface at the certain region. Where? At the equator or at the poles. Where it is having a flat surface, guys? Everyone?
Equator.
No. Mari, you are completely wrong. I already taught you, but you are not remember. At the poles. So what will happen? At the poles, the Earth is having actually less radius than at the equator line. So if you have noticed it, Earth is not a completely sphere. It is having a flat surface at the poles. That is what I have taught you already. So what will happen now here? If you observe very carefully, this is the equator point and this is the pole point. Now you tell me where the radius is maximum, at the equator or at the poles? Everyone? Where the radius is maximum, guys? At the equator or at the poles? Please respond. Where the radius is maximum from the center?
Equator.
Equator. This is what we used to call as latitude. Okay. So now, if you notice what is the G value formula? G is equals to capital G into capital M divided by R square. Now I write the G value for G value at the poles. G value at the poles, tell me everybody. G value at the poles is equal
So
to
what